The Phlegraean fields, or Campi Phlegraei, are a vast and mysterious volcanic area located just to the west of Naples, Italy. This region is steeped in both natural wonder and ancient legend, drawing the curiosity of scientists and travelers alike. Unlike the iconic Mount Vesuvius, which rises as a single peak, this supervolcano is a sprawling landscape dotted with fumaroles, bubbling hot springs, and dramatic craters that stretch across the countryside. The fields cover an immense 13-kilometer wide caldera, a massive depression formed by ancient cataclysmic eruptions that shaped the land thousands of years ago. Its sheer size and long history of intense volcanic activity make it a truly unique geological wonder unlike any other volcanic region in Europe. The ancient Romans called it the Burning Fields, a name that reflects the constant presence of steam, fire, and heat that has shaped both the landscape and the myths of the area. As one of the very few supervolcanoes on Earth, Campi Phlegraei has the potential to unleash eruptions thousands of times more powerful than those of typical volcanoes, rivaling the mightiest eruptions in history. Such a colossal eruption could have catastrophic consequences, not only for the local area, but for the entire planet, affecting climate and life on a global scale. The dense population living nearby, including the bustling city of Naples, makes this one of the world's most dangerous volcanic regions, with millions of lives at risk. An eruption could occur with little warning, making the Phlegraean fields a ticking time bomb in the heart of Europe and a constant source of concern for scientists and residents alike. That's why understanding and closely monitoring the Phlegraean fields is absolutely crucial for the safety and future of millions of people living in its shadow. The Phlegraean fields have shown signs of unrest for decades, making this region one of the most closely watched volcanic areas in the world. Scientists and local residents alike remain alert to even the smallest changes, knowing that these signals can provide crucial early warnings. Ground uplift is one of the most noticeable indicators caused by magma moving and accumulating beneath the surface. This slow but steady swelling of the earth can reshape the landscape, sometimes causing roads and buildings to crack or tilt. In some areas, the ground has risen by several meters over the years, signaling increased volcanic activity and pressure building below. Such dramatic changes are rare, but when they occur, they capture the attention of both scientists and the public. Small earthquakes, often too faint to feel, are another key sign of unrest. These tremors are carefully recorded and analyzed, as they can indicate the movement of magma or shifting faults deep underground. Their frequency and intensity have been rising in recent years, suggesting the volcano is becoming more active and that changes in the subsurface are ongoing. Gas emissions from fumaroles are closely monitored for changes in sulfur dioxide and carbon dioxide. These volcanic gases can escape through cracks and vents, providing valuable clues about the state of the magma below. These changes can reveal shifts in the magma chamber below, helping scientists predict possible eruptions or changes in volcanic behavior. Scientists use this data to assess eruption risks and warn local authorities, ensuring that emergency plans can be activated if needed, and that communities remain prepared. The scale and potential impact here make tracking these signs especially important, as millions of people live in the shadow of the volcano, including the city of Naples, just a few kilometers away. Ongoing activity is a constant reminder of the immense power beneath the surface and the need for constant vigilance to protect lives and property in this unique and dynamic region. Monitoring the Phlegraean fields requires advanced scientific tools and teamwork. Seismographs record small earthquakes, helping pinpoint magma movement. Satellite radar tracks even slight ground deformation, offering a broad view of changes over time. Gas samples from fumaroles are analyzed to understand underground processes. Combining seismic, satellite, and gas data gives scientists a comprehensive picture of volcanic activity. This information is vital for early warning systems and public safety. Continuous monitoring helps scientists provide timely alerts to reduce risk. Staying ahead of this sleeping giant is essential for protecting millions nearby. The work never stops. Vigilance is key. An eruption of the Phlegraean fields would devastate the local area, unleashing immense power and destruction. The immediate surroundings would be transformed in moments, with landscapes altered and communities facing catastrophic consequences. Over 3 million people, including those living in the bustling city of Naples and its suburbs, are at risk from the eruption's direct and indirect effects. Pyroclastic flows, fast-moving currents of hot gas and volcanic matter, could destroy everything in their path, obliterating buildings, infrastructure, and natural habitats within minutes. Ashfall would blanket large areas, coating streets, homes, and vehicles, causing severe respiratory issues, disrupting daily life, and making transportation hazardous. The ash cloud could spread across Europe, drifting for hundreds or even thousands of kilometers, affecting air travel, grounding flights, and damaging crops and agriculture far from the eruption site. Tsunamis are a real threat due to the caldera's proximity to the sea, with the potential to send powerful waves racing toward nearby shores. Displaced water could generate waves impacting Mediterranean coastal communities, flooding towns, and causing further destruction along the coastline. The disaster's effects would extend well beyond Italy, potentially affecting the entire continent, with disruptions to transportation, trade, and daily life. Economic, health, and environmental crises could follow, straining resources and overwhelming emergency services across multiple countries. Preparedness and international cooperation are vital to mitigate these risks, ensuring a coordinated response and helping communities recover from such a far-reaching disaster. A super eruption here could trigger global consequences. Massive amounts of volcanic gases, like sulfur dioxide, would enter the stratosphere. These aerosols reflect sunlight, causing temporary global cooling. Cooler temperatures and less sunlight could lead to crop failures and food shortages. The global economy would suffer, with disruptions to trade and industry. Ash clouds could ground flights for weeks, creating travel chaos. The aviation industry would face major challenges ensuring safety. These effects show how interconnected our world is. A super eruption would be a global crisis, not just a local one. History offers stark reminders of volcanic power. Mount Tambora's 1815 eruption caused the year without a summer, leading to global crop failures. Krakatoa's 1883 eruption triggered deadly tsunamis and altered weather worldwide. Mount Pinatubo in 1991 released huge amounts of sulfur dioxide, cooling the planet by 0.5 degree Celsius. These events show how eruptions can disrupt climate and society. They provide valuable lessons for understanding the risks at the Phlegraean fields. Preparedness and scientific study are essential to mitigate future impacts. The past warns us to take volcanic threats seriously. Despite scientific advances, many mysteries remain about the Phlegraean fields. Predicting exactly when an eruption will occur is still a major challenge. Magma movement and its interactions underground are complex and not fully understood. The triggers and likelihood of a super eruption remain uncertain. These unknowns make precise risk assessments difficult. Continued research is needed to improve models and predictions. Better understanding will enhance our ability to respond to volcanic threats. Authorities have developed safety plans to address the threat of the Phlegraean fields. Evacuation routes and shelters are mapped out for at-risk communities. Public education campaigns ensure residents know the risks and how to respond. Regular drills test emergency plans and improve coordination. International cooperation, including the UN and EU, strengthens preparedness. Collaborative research and data sharing enhance our understanding and readiness. These efforts are vital for minimizing the impact of a potential eruption. Ongoing research and monitoring are essential for managing the risks of the Phlegraean fields. Advances in technology have improved our ability to detect unrest and predict eruptions. There's still much to learn about the complex processes driving volcanic activity. Investing in research leads to better tools and more accurate forecasts. Collaboration among scientists and governments builds a global network of expertise. Sharing data ensures we're better prepared for future threats. As our understanding grows, so does our ability to protect communities. Science and vigilance are our best defenses. The Phlegraean fields are a formidable natural threat with global implications. Constant monitoring and scientific study provide crucial insights into its risks. Preparedness through safety plans and public education is key to minimizing impact. International cooperation builds a stronger response to supervolcano threats. Vigilance and research remain our best tools for protection. As we learn more, we must stay committed to understanding and mitigating volcanic dangers. Working together, we can safeguard lives and the environment for future generations.